Hello, this is Marsh Mathematics. It's the second video on differentiation, and it follows on from the video on the chain rule. It's about connected rates of change. Okay, so we're going to have a look at two examples. One sort of quite easy one and one quite difficult one, but they both could be exam type questions. Okay, so the first thing we're going to have a look at is what they require in the question. Now, so the first thing to do is to highlight what they're actually after. They're after the rate of change of depth of the reservoir. Now, the depth of the reservoir is y. Okay, and when it's a rate of change, okay, they mean with respect to time. So they want to find dy by dt. Okay. And this is when the width is x. So when x is equal to 15 and is increasing at 0.2, so that means that dx by dt is equal to 0.2 meters per day. Okay, I mean, just forget about the units for now until we get to the end of the question. Okay, so it's got that restriction for x as well. So what do we need to find? We need to find dy by dt. So what springs this to mind is that we've got the chain rule. Now the chain rule is going to help us here, because how we're going to find dy by dt is by looking at the chain rule. Now dy by dt, okay, if we put dy on the bottom, okay, and we put dy on the top and dt at the bottom, we've got three variables here. We've got y, x and t. Y, which is the depth, and x, which is the width, and t is time. They're all connected to each other. The three variables are connected to each other, and they're connected through the chain rule. The rates are connected. Okay, so the other variable is x. Okay, the other variable is x, and so we can write the chain rule like that. Okay, because the reason we can do that is because these two dx's actually cancel each other out, and so dy by dt is equivalent to that. That's how the chain rule works. Okay, so we need to find out what dy by dx is, but we already know what dx by dt is. Okay, so we can find dy by dx because y equals x squared over 50 minus 2. So if we differentiate that, we get 2x over 50, okay, which is x over 25. But we know that x is equal to 15 at that point. Okay, so dy by dx is going to be over 15 over 25. So that cancels down to 3/5. Okay, so we found out what dy by dx is, but we already know what dx by dt is at that point, which is here. Okay, so now we can go back to this and we can write dy by dt is equal to 3/5 times dx by dt, which is 0.2. Okay, and that comes out to be dy by dt, okay, 0.12, and we put the units in now, which is meters per day. Okay, now that is what we found. That's the rate of change of depth. Okay, so that's how it's connected. That's how three variables are connected. Now the next example, I've written it out already, but it's a bit more complicated, and that one would be maybe a section A type question, an easier type exam question, whereas the next one is more involved. Okay, and so we've got a vessel here. Now I've written it out and I'm just going to go over it and explain to you what I've done. Okay, so this time there's no diagram, and so a potter is making an open top vessel, and so the first thing to do is to draw the diagram, which I've done here. Okay, it's got a radius of r, but it's got a height of 2r. Okay, now it says first part is show that the volume of the vessel is given by this expression. Okay, well you should know that the volume of a cylinder is pi r squared h, but h is 2r now, that's h. Okay, so you multiply that together and so we're good finding the volume. Right, now the second part, there's only 1 mark. The second part we've got 4 marks and we've got 6 marks here. So part B, it says find the rate at which the volume is increasing. Right, so that part there is dv by dt. Okay, when the radius is 2, and I've put it over here, right, so the thing is to get all your information together, and it is increasing at 0.25 centimeters per second. So all my information is there. Now what I do is, if I want to find this, I write it out as a chain rule. Okay, as part of the chain. I want to find dv by dt, so I know it's going to be dv over something, and dt is on the bottom. Well, the other variable, what are the variables we've got here? Well, the variables are v, t and r, so the other variable must be the one on the bottom when it is. Okay, that's how you can work out. That's where people find it a bit difficult, finding out how to write the chain rule. Okay, but write the two, find out what you need to find out, and then the other variable, you know where to place the other variable. Now so we need to find dv by dr. Well, we've got v, you got this expression here, and from this expression we can find dv by dr. We differentiate it with respect to r. Okay, but we know that r is 2. Okay, so we can put that in a minute, but also we know what dr by dt is. They've told us what it is. It's 0.25, so we can substitute it into there. So we substituted both those values into this expression to get dv by dt, but we know that r is 2 at that point. Okay, so then we can substitute it in and we end up with a value for dv by dt. So that is slightly more complicated, that part of it. Okay, that's why I've written it out and gone over it so you can look through. Now the last part is even more complex. This is a sort of difficult type of question you get in an exam question. This time they said given that the volume is increasing, okay, at this rate, so let's write what that means. So let's write that down. When the radius is 5, okay, find the rate at which the surface area is increasing at this point. Find dA, but so I should have written there when r is 5. Now how do we find out? It seems that this is why it's 6 marks. How do we find that? So what we have to do is find a formula that connects A and R. Well, you should know that the area of an open cylinder will be, if it's a closed cylinder, it would be 2 pi r squared. So that's the base. So we've just got it like this. Okay, so we've just got the base, which is the pi r squared. And if we open it up, if we cut it open, this would be L, and this would be 2 pi r. But we know that L is equal to 2r, its height. Okay, so that's how we get the area of that is 2. That's going to be 4 pi r squared. Okay, that's how I've got this value. So we find out that the surface area for an open top cylinder is 5 pi r squared, so we have to calculate that. Now we need to find out, we want to find out what dA by dt is, right? But so again, what we write dA at the top and dt at the bottom, but the other variable is r. So that's how we form our chain rule. Okay, now we know there's something we need to find out, dA by dr, so we can find that using this expression up here, this formula. We differentiate we differentiate A with respect to r, and we get 10 pi r, but we know that r is 5 at this point. Okay, so that's 50 pi. I'm just going to leave it in terms of pi for now. So we found dA by dr, okay, but how do we find dr by dt? So so we have to go back to the other part of the question. Well, we know that dr by dt from the chain rule, okay, is dr by dv times dv by dt. Okay, I've just inverted this now. Okay, so remember, how do I do it? I place this one on the top and this one on the bottom, and the other one connecting them is v. So I know it must be dv on the top on here and dv there. Now we know that d from the last part of the question, if you look up here, we know, okay, we found it up here, that there's a general formula that we found for dv by dr is there. So we can say, well, that's 1 over. So that means if that's dv by so then dr by dv, okay, dr by dv is equal to 1 over 6 pi r squared. Okay, so then we can substitute it into here, and we know that the value is r of r is 5. Okay, and then we can calculate what dr by dt is. Then we can go back and substitute it into there, okay, to find dA by dt. Now that is a pretty complicated question, because we're having to use the chain rule 3 times there, okay, but it's just to show you how an exam question, a difficult exam question, can be, okay, where you have to use all the information, and that could be quite a difficult section B exam question on connected rates of change.